STA2322 Data Analysis Using Statistical Packages. Lesson 7 ANOVA and ANOVA. Learning Outcomes. What is ANOVA and ANOVA? Theoretical background of ANOVA and ANOVA. Types and assumptions in ANOVA. Partitioning of the variance in ANOVA. Hypothesis p-value. Entering data into the SPSS worksheet and commands used in performing ANOVA. Perform ANOVA and interpret the output tables. ANOVA means analysis of variance. We get these red color letters and form the word ANOVA as an abbreviation. Analysis of variance, which is usually shortened to ANOVA, is most commonly used statistical method for testing hypotheses about 3 or more means. You know that already we discussed about the t-test. So if we have to compare 2 means, we use t-test, but we have 3 or more means, we have to go for a ANOVA test. The ANOVA statistic is called the F-test after it is developer Fisher. So this is also called F-test. We use ANOVA when we want to test the null hypothesis that 3 or more means are drawn from the population. So if we have 3 or more means in a population, so we can take the sample n1 from the population 1 and sample n2 from the population 2 and nk from the population k. So mean and variances we can take x bar 1, x bar 2 and x bar k, and variances s1, s2 and sk. A one-way analysis of variance is way to test the equality of 3 or more means on time by using variances. So one-way ANOVA we are taking to compare 3 means within one time. These are the samples. So what's wrong with t-test? If we have 2 means, we use the t-test, which turns to be just a special case of ANOVA. So if we have two means, we can use the t-test. If you want to compare 3 or more groups using t-test, which is usual 0.05 level of significance, you would have compare with 3 groups pairwise. So we know that we can use only 2 in t-test. So if we need to check 3 or more, we have to use pairwise. Suppose we have 3 groups called A, B, C. First we have to compare A and B, then B and C, also A and C, right? So that's why we can that's how we can compare these means using t-test. So chance of getting wrong results would be, so this is the chance of getting wrong results, because level of significance is 0.05, that is 14.3%. It wanted to compare 4 or more groups, chance of getting wrong results would be that is 0.95 to power 6. It could be, because that is 5 groups, that is 40%. So if it is 5 groups, that is 40%. Then if it is 4 groups, we have to compare pairwise all the groups. So like the T, F depends degrees of freedom to determine the possibilities and critical values. So instead of using t-test, we can they introduce the F-test. So then the chance of getting wrong results should be reduced if you use the ANOVA test. But is the difference between T and F is the terms of degrees of freedom concept. So this is the F has 2 different degrees of freedom to calculate. So in the F-test we have to calculate 2 different degrees of freedom. And in contrast, T has only one formula for calculating degrees of freedom. But F has 2 types of ANOVA. One-way ANOVA, it means one factor has many levels, right? Right. So it means if you have a factor called smoking stated, there are 3 levels, that is never, form and current. One-way ANOVA is an extension of the t-test to 3 or more samples. So that's I explained earlier also. Then second type is two-way ANOVA. Two-way ANOVA means 2 factors, that is example gender and smoking status. Three-way ANOVA means 3 factors, gender, smoking and beer consumptions. Assumptions for ANOVA. So when we before conducting the ANOVA, we have to do these assumptions. First one is normality assumptions. It means the populations from which samples were obtained must be normally or approximately normally distributed. So these data should be normally distributed, otherwise we can't perform an ANOVA test. Second one is homogeneity of variance. It means the variances of the population must be equal. So if we draw the samples from various population, then variances of these population must be equals. Then all treatment populations have the same variance. This variance is called error variations. So if we take 3 populations, so these variance means these distances should be equal. So it means sigma 1 equals sigma 1 2 equals to sigma 3. That is called error variation. That means sigma error. So sample estimate of variance. Sample variance, we know that how to find the sample variance. This is formula. Using this formula we can find the sample variance. This distance from any data point to the mean is deviation from this point to the mean. That is xi subtraction x bar. The sum of the squares is the sum of all squared deviations. So this is a sum of all squared deviation, xi minus x bar squared, sigma equals 1 to n. Partitioning of the variance in ANOVA. So we can partition this variations all observations equals variation between each observation and each group means plus variation between the group means and overall mean. So we can partition this variance in the ANOVA as this. In other words, total sum of squares equals within group sum of squares plus between group sum of squares. We denoted this within group sum of square SSE, or sometimes that is called SSW also, and between group sum of squares called SSB or SST. Then total sum of squares, this one we can denote it as SST0. This is the sum of the square deviations between each observation and overall mean. Overall means grand mean. So that we can take this equation SST0 equals sigma I equals n to n, x n I equals 1 to n, xi minus x bar whole squared. As we can deduce from formula, it is sample means are closer to each other of all of the sample means would be close to grand mean, and it results SST would be small. So it large existence, it should be SST0, right? If large differences exist between the sample means, at least some sample means differ considerably from the grand mean, producing large values of SST0. Then we have reject the null hypothesis, and we should know which value of SST0 should have to reject it, right? Then for this we can term called within treatments variation, which is denoted by SSE, sum of square of for the error, or SSW. I explained this earlier. Within group sum of square SSW, or error sum of square SSE, right? This is a way of finding SSE. This is the sum of square deviation between the observation and mean of the group which it belongs. So SSW we can calculate I equals 1 to n xi subtraction x bar group. It means if we have 3 groups, so how we can find SSW? Xi minus x bar group. It means first we have to consider one group, and we have to take the mean of that group, then subtracting all the elements in this group, so we have to, and then add, we can find SSW. I explained how to do this using an example. Just take this idea, this is the theory of how to find SSW or SSE. So this is the same equation. Sum of the squares between SSB or SST. So sum of square for the treatments. This is the way of finding the SST. This is a sum of square deviation between each group mean and overall mean, weighted by the sample size of each group if there are n groups. So so this is the way of finding this nj means if we have there are 3 groups, this then if we need this grand mean, it means overall mean. So if we find the sum squared for treatments, what we have to do is, if you take 3 groups I told you, then n1 times x bar group 1 subtraction overall mean squared plus then n2 x bar 2 subtraction overall mean squared plus n3 x bar 3 subtraction overall mean squared. Likewise we have to find SST for all groups, mean of mean square for groups. Then next we can find mean square for the groups, that is MST, that is equals to SST over k minus 1. So you have to remember these all equations, because when you're doing the manual calculation you need those equations. So k is equals to the number of treatments. Number of treatments means how many groups we have. So if there are 3 groups, k is equals to 3. Mean square for array, MSE, or mean sum of square within groups. So we assume the variance sigma squared is same for the each group's populations. We can pool or combine the estimates of sigma square across groups. We use an overall estimates for the common population variance. So then we can find MSE equals SSE minus n minus k. N is equals to all the observations. It means if we have 3 groups, if each group have 10 observations, then all the observation means 3 into 10, that is 30. Then n minus k, we can find 30 minus k. Number of observation for treatment T. So test statistics goal, compare 2 scores of variability MST and MSE. So test statistics is if the f value we can take MST over MSE. Then I explained how to find MST and MSE. Then if f is small or closer to 1, then variability between the groups is negligible compared with the variation within groups. The group does not explain much variation in the data. If f is large, then variability between the groups is large compared to the variation within groups. So the grouping explains a lot of variation in the data. General ANOVA summary table for completing the randomized design. So if we are doing the manual calculation, so we need to find all these things: treatments, then error, degrees of freedom for treatments, degrees of freedom for the error, and total degrees of freedom, and SST. So this is the sum of squares for the treatments, this is sum of squared for the error, and this is the sum of square total, that is SST 0, and this is the way of finding MST, that is SST over k minus 1, and MSE you can find SSE over n minus k. Finally you can find the MSF using this equation, MST over MSE. So you need to remember all of these equations, and then here there are another 2 equations, so you have to remember these 2 also. Then after that you can find the f value. After finding the f value, you can find again the critical value by using the f table here. Then by considering the critical value and the calculated value, if the calculated value is greater than the critical value, what you can do is you can reject the null hypothesis in favor of alternative hypothesis. Otherwise you have to accept the null hypothesis. So this is the example. Evaluation of training programs, that is a goal to see if there is a significant difference in learning time using the different training methods. So we can write the null hypothesis H0 as there is no significant difference of different training methods. Then the alternative hypothesis would be there is a significant difference of different training methods. This is the data. So now you can find manually by using the explained equations, and you can take the t value. Right, these are the given data. So we know that so we need to find f. To find f, what is our formula? F is equals MST over MSE, no? Right? Then to find T and MSE, so we know that MST equals SST over k minus 1, and MSE equals SSE over n minus k. Right? Then we have to know what is k. K is number of treatments, here 4. Then we can find k equals 4. Then n equals total number. Total is 12. then 12 minus 4 n minus k also we can find. Then SST equals, what is the formula for finding SST? Sigma I equals 1 to n nj ni times xi bar minus x double bar, no? And this is the equation for finding SST. Then SSE we can find xi sigma xi minus x bar I, no, square. So the by using those equations, so we can find f, right? So we will consider step by step how we can find the f value, right? First of all, we need to find the total of these things. So before that, how many? All three, no? Then n1 is 3, n2 is 3, n4 3 is 3, n4 is 3. Then here 17, that is 27, then 11 20 36, and here 21 plus 9 30, no? And here what is the value? 66, I think, no? Right. So then we can find the mean equals 27 divided by 3, that is 9, here 12, here 10, and here 22. These are the means. Now we can find the grand mean. How we can find the grand mean? We have to add all of these things and divide by all is 12, no, 3, yes. So we can add now 27 plus 36 plus 30 plus 66 divided by 12. So grand mean is 13.25, then that is 13.25. okay, now first we need to find SST, no? SST equals sigma ni times x bar I minus x double bar squared. So so it is better to find this first x bar I minus x double bar, no? Then we can square it. So we will find that x bar I means here, x bar I means what is it? Here 9 minus 13.25, then square it. Like first I wrote those things. SST equals nj equals ni equals 3 multiplied by 9 minus 13.25 square plus 3 multiplied by 12 minus 13.25 square. I am writing here SST, right? Then we can write the answer now. Plus 3 times now 10 minus 13.25 square plus 3 times 22 subtraction 13.25 square. So then we can find SST. Then here 3 is common, then we can take 3 out from the brackets. If these sizes are different, 3 is not common, right? So sometimes here there may be 3 observations, here may be 4. So then that sample size is not always same. Here same, so we can take 3 out from the bracket. So then 9 minus 13.25 square, no? 18.063, no? Yeah, 063, 18.063, 18.063 plus 12 minus 13.25 square. 1.563 plus next one is what is it, 10 minus 13.25 squared, no, 10 minus 13.25 squared, 10.563 10.563 plus 22 minus 13.25 square, the value is 76.563, 76, no, 76.563. right, now we can add this all, 18.063 plus 1.563 plus 10.563 plus 76.563, then we can take the answer as 106.753. then we need to multiply the whole by 3, then we can find SST as 320.256, 20.256. then SST we found 320.25. this is the value of SST. now we have to find SSE, right? SSE equals sigma xi minus x bar squared, no, so it means we have to find xi minus x bar. so first we can write x1 minus x bar, x I minus x bar 1 squared, then xi minus x bar 2 squared, xi minus x bar 3 squared, and xi minus x bar 4 squared. so then here xi means 10, 10 minus 9 squared means 1, 9 minus 3 means 6, 6 squared is equals 36, 8 minus, sorry, 9 minus 9 0, 9 minus 9 0, then 0 squared means 0, 8 minus 9 minus 1, that is 1, no, so we can take the total as 2. then x bar 2 we have to consider, that is 12, 1 minus 11 minus 12 minus 1 squared plus 1, 16 minus 12 4, that is 16, then square, 9 minus 12 3, 3 square means 9, there 25, that is we got that as 26. then we can consider this one, xi minus x bar 3, that is 13 minus 10 3, then square 9, 8 minus 10 2, square means 4, then 9 minus 10 minus 1, square 1, we can take the total as 14. right, finally this one, 18 minus 22 4, 4 to the power 2 means 16, 23 minus 22 means 1, 1 to the power 2 means 1, 25 minus 22 means 3, 3 to the power 1 9, that is means 10, that is then, sorry, 26, no, here 26. alright, then we can find SSC, total of this all, 2 plus 26 plus 14 plus 26, so here 52, 56, 66, I think that is 68, no, now we found SSE as 68. now we have to write n me, if you take all number of observation, that is equals 12, then k equals number of treatments, that is 4, Next you need to find n minus k minus 1 and n minus k, right? K minus 1 equals 4 minus 1 equals 3, and n minus k, that is altogether how many? 12. 12 minus k, 12 minus k means 8. N minus k equals 8. So now we can find MST and MSE, no? First we can find MST and then MSE. MST equals SST over k minus 1. SST we found through 320.25. K minus 1 equals 3. Then what is the value? 320.25 divided by 3, that is 106.75. 106.75. And then we can find MSE, that is SSE over n minus k. SSE we found as 68 and n minus k 8. Then we can find 68 divided by 8, the value is 8.5. Then MSE we found as 8.5. Now we can find the F value. F equals MST over MSE, right? So MST equals 106.75 divided by 8.5. 106.75 divided by 8.5, that is 12.559, no? The answer is 12.559. This is the calculated F value. So this is F calculated value, that is 12.559. Then we can find the F critical value or F table value. So our significance level is 0.05, and our number of treatments, that is we call that n minus 1, that is 4 and 8. So we need to find this by using the F table. Sorry, not 8 here. So we need to find 3 and n minus k, and what is our total? 12 from the F table, right? This is the F table. So first you have to choose the correct page, that is F table for alpha equals 0.1. So we need 0.05. So we have to choose that one. Alpha equals 0.01, alpha 0.01. This is alpha equals 0.05. Then degree of freedom 1, that is k minus 1, no? That number of treatments, that is k minus 1 is 3, and next we have to choose 12, no? 3, 12 is there. This is our value, that is 3.4903, right? You can find this using that 3, that is 3.4903. Then we can write our conclusion, right? So this is 0.55, then k minus 1, that is 4 minus 1 3, and this is not n minus k, this we have to choose n, that is 12, right? Sorry, there is a mistake. So we need to choose not n minus k, right? So then n minus k means that is 8. So it should be also n minus k. It means we have to choose this 8, right? This should be 8, not 12, right? That is mistake. Then this is the way of choosing this n minus k, that is 8. And this is the correct. Then this 4.06 62. Four point 4.0662. This is the correct value, right? 4.0662. okay, now we can go further. That is k minus 1 and n minus k. K minus 1 number of treatments equals 4, and n means total number of observation. We have 12 observations, then 12 minus k, that is 8. 12 minus 4, 8. Then we can find our f value is 4.0662, right? This is our critical value. Then f value we found as 12.559, and alpha equals our 0.05. so then here that is then this is 4.0662, right? This is 4.0662, right? Then our calculated value is greater than the critical value, so we can there is enough evidence to reject the null hypothesis and accept the alternative hypothesis as we did previously. So if we this null hypothesis, so calculated value is greater than the critical value, what we can do is we can reject the null hypothesis in favor of the alternative hypothesis, right? Then hypothesis p value. Hypothesis p value is another method of testing hypothesis. P value shows the probability your sample test statistics opposed to the null hypothesis as true. The smaller p value, the less support for the null hypothesis, and so the higher the probability support for the alternative hypothesis. For example, a p value is of 0.55 indicates the high support for the null hypothesis, so that cannot reject the null, right? A p value of 0.001 indicates a low probability the null hypothesis is true, so support of rejecting null hypothesis. The practical approach is to calculate the p value is and compare with the level of significance, that is alpha. If the p value is smaller than alpha, we can reject the null hypothesis. So we knew these things. For example, p value is 0.0001 and alpha is set to 0.05. what happened? You can strong evidence to reject null hypothesis because p value is much smaller than alpha. The smaller p value is in relation to alpha, the more the evidence for the rejecting the null hypothesis, that is p value, and this is alpha. So p value is greater than alpha, do not reject the null hypothesis. If p value is less than the alpha, we can reject the null hypothesis in favor of alternative hypothesis. This is a table you can see. Then see if p greater than 0.1, what happened? No significant evidence to reject the null hypothesis. P value in between 0.1 and 0.5, weak evidence rejecting the null hypothesis. P value is less than 0.5 but greater than 0.01, strong evidence rejecting the null hypothesis. P value is less than 0.1, are the overwhelming evidence to reject the null hypothesis. These things you knew, these we discussed in the previous lessons. And rejection region and p value, the purpose of the calculating f statistic is to determine whether the value of SST is larger enough to reject the null hypothesis. If SST large, f will be large. F equals MST over MSE. MST equals SST divided by k minus 1. Hence we reject the null hypothesis if and only if f alpha k minus 1 n minus k, that is the critical value. So if calculated value greater than f table value, what we can do is if alpha equals 0.5, the rejection region of the particular example is, right? So this is a way of we are rejecting the null hypothesis using the p value approach. So now we consider how we can do this using the SPSS. So example, I take the same example. So goal is to see significant difference between the learning time and using the different training teaching methods. Then alternate null hypothesis, there is no significant difference of different training methods, and the alternative is there is a significant difference of different training methods. So this is the data. So already we use those data, and method is treatment or independent variable. That's the training method. That's variable is 1 in SPSS. Learning time, that is variable 2 in SPSS, right? Remember, so then these things you did in the t-test also, right? Remember, independent variables much are experimentally manipulated by an investigator are called independent variables, and dependent variables which are measured are called dependent variables because they are presumed to depend on the value of the independent variable. So entering the data into the SPSS data edit sheet, so you know that how to enter those data. Use the dummy values, that is 1 2 3 4 to enter the independent variable method. So you did this in test also. We take what is method 1, method A as 1, method 2 as, method B as 2, method C as 3, and method D at 4. Then you can label those things, what is 1 2 3 4, so that the independent variables, that is numeric data, can be used in the ANOVA. After you enter the data, should be get following data within SPSS, so you can enter those data. So one for training method, these are the methods. So we there under one you can enter these things. You have to take only 2 columns, and you can because I told you that only one independent variable, it has many treatments, it means many levels. So there are 4 levels, so you need to enter the independent variable into the one column called 1 2 3 4, and you have to label what is 1, what is 2, what is 3, and what is 4. Carry out the explore data analysis to check the one assumptions. What is our assumptions? Normality assumptions. We have to check normality of this data. If that is not normal, you know that how to transform this data into the normal distribution, and taking transformations like transformation, square root transformation, any other transformations. Otherwise, if this data is not normally distributed, we can't perform the ANOVA test. So we can we can check the normality of the data and analysis, descriptive, and explore, and click through the following menu sections. Analysis, then compare means one way ANOVA. This is the way of we can use the what is it we can perform the ANOVA test. So once you goes to this window, you can see a window like this. Then you should following window pop up by clicking and dragging the learning time to the dependent variable. So you have to add the learning time to the dependent variable, and training methods for the independent, that is factor, right? Then you can see like this way. Okay, so we will do practically, and I will show you how you can do this. Just take this idea. So that is the way we have to do this. And click options button, then you have to click on options, then this is option button, and you can see this one. So you have to click on the descriptives and homogeneity of variance test, because I explained, you know, that is the other assumptions, that is homogeneity of variance. So we have to perform click on this one, check this homogeneity of the variances, check descriptives and homogeneity of variance box, and click continue. Then perform the multiple comparisons in the ANOVA dialog box. So these the multiple comparisons. We have to click the post hoc button. Then there are so many tests. You can use one of those methods. So SNK or the Turkey methods. Most frequently we are using the Turkey methods. So here I used 3 methods. So you can use any one method you like. Click continue and click OK. Then you can see these outputs. Before see the outputs, we will go to the SPSS worksheet and manually we can do practically those things we discuss in those slides. Right, this is the entered worksheet. So you can enter the learning times, that is the 2 variables. This is the independent variable, and this is the dependent variable. So independent variable has 4 levels, so you can use these 4 levels in that way. And so you can label this, what is 1 2 3 4 in here, right? Okay, then so we can label what is 1 2 3 4 no treatments. Yes, what is 1 is method A, and 2 is method B, and 3 is method 4, method C, and 4 is method D, right? These are our labels. So then first thing is we have to check the normality. So what you have to do is analysis. So we can descriptive statistics, we can take the explore and so explore. So dependent variable is what is it, our learning time dependent variables. Then factor, that is factor is training methods. So then we can take these statistics, okay, or we can use the easy method. What is it, to find the normality? So we can go to the, we know 3 things, so I will show you another one, so you know that how to find the normality. Also we can go to the frequencies, and our variable is dependent variable is training method, and go to the statistics, no, not the statistics, in charts you can see that histograms with normal curve. Then continue, okay. So then we can check the normality of these data. Yes, our data set is normally distributed, right? So then if since this is normally distributed, we can use the ANOVA test. So what we have to do, analysis, compare means, one way ANOVA, and one way ANOVA. So then what is our dependent variable is learning time, no, and our independent, that is factor list, means training method. And next we have to go to the options as explained in the slides, then descriptive and homogeneity of the variances, continue. Then we have to go to the post hoc. So here significance level is there, so, and we can click any one method we like. I choose these two, SNK and Turkey. Continue, then press OK. So then we can see these outputs. Descriptive statistics is there, then homogeneity of variance test is here, then ANOVA, then post hoc test, and homogeneous subsets. So you can see those things in the output window. Now we will see how we can interpret those data, right? These are the output we can take. So first one is the descriptive statistics. So it is given the maximum, minimum, mean, standard deviation. So here, so mean of the ABCD is given here, no? So we calculated those things. If you can check your manual calculations are correct or not in here. The mean of standard deviation and other descriptive parameters are given the descriptive box. And homogeneity of the variances, so it means you know that our assumption, so we have to check the variances are equal or not. So p-value indicated the equal variances. If our p-value is greater than 0.05, so it is 0.2, that is greater than 0.05, it means the variances are equal. So here the variances are equal, right? So the significance value of the homogeneity of variances is greater than 0.05. So the variances of group are significantly not different. So this is the theory. If we take the Levin's statistics, p-value is, that means homogeneity of variance, p-value is greater than 0.05, it means the variance of the group are not significantly different, it means they are equal. So then we can take the ANOVA table, right? In the ANOVA table, so here we can use our significance value to reject or accept the null hypothesis. Here before that you can find the sum of square. We found as 320.25 and within groups that is 68. So did you remember that? So then these are the degrees of freedoms, no? K minus 1 is equals 3, n minus 1, n minus k is equals 8, and these are the MSE values, mean squares, MSE and MST values. So here given, then F1, F statistics, MST over MSE, that is 12.559. And also here the additional thing we can see with this, which we are not calculated in our manual calculations, that is significance value. So here significance value is 0.002, that is less than 0.05. If that is less than 0.05, what we can do is we can reject the null hypothesis in favor of alternative hypothesis. So the significance value is compared in the group's training method is less than 0.05. It means, so we could reject the null hypothesis. What is our null hypothesis? There is no significant difference in the mean learning times with each different teaching methods. So if we reject the null hypothesis, what is our conclusion? It means we can write the conclusion as there is a significant difference in the main learning time scores within the three different teaching methods. However, these results do not tell which teaching methods are responsible for these difference. Yes, then here we found there is a significant difference, but we don't know where that difference is. So that we need to find the post-hoc test to find the where the difference is. Right? So SPSS kindly flag. So you can see the asterisk marks which differences are significant. So result teaching methods 4 produces significantly different results from the other teaching method. So if you see these things here, you can see the flag here. What is it? 1 and 4. Here also a flag. 2 and 4. Here also a flag. 3 and 4. And if you take the fourth method, it means method D, all are flags. It means the mean difference is significant as 0.05. It means teaching method 4. It means teaching method D is different than the other methods. There's the difference. So there you can, these are the homogeneous subsets. So you can go to the homogeneous subset, then you can they are the subsets, then subset 1. So if you can use one method you like here. So I use two methods, so SNK method and Turkey method. So if you can take only one method, that is enough. So according to those methods you can see the subset 1. What is it? 1, 3, 2, that is in a one set, and 4 is another set. So here then differences in the, if you choose this one, that is also 1, 3 and 2 in one group, and 4 is in other group. So 4 is different than the other groups, right? So this is the way of interpret those data. Homogeneous subsets separate the teaching methods 4 from other methods, so it is separated. Formal reporting, then when we report outcome of an ANOVA, we cite the value of F ratio and give the number of degrees of freedom outcome and the significance value. So in this case there is a significant difference between the learning time scores for the teaching methods 4 and teaching method 4. That is significant difference is in the teaching method 4, because we know that there is a significant difference, and we found where the difference is, that is in the teaching method 4, and the other three teaching methods are tested. Right? So other three methods are in the one group, then these are in the other group. So you have to write the conclusion as this way, where's the difference is also we need to write. So this is our t value, f value, and this is 0, then our p value is less than 0.05. And now we consider about the ANOVA. Right? So we are not going to consider how to calculate ANOVA in the manual calculations. Only we are going to learning how you can do this ANOVA in SPSS. So the analysis of covariances, that is ANOVA, is a technique that sits between analysis of variance and regression analysis. So this is in between analysis of variance and ANOVA and the regression analysis. It has a number of purposes, but the two that are perhaps it is most important case one is to increase the precision of comparison between groups by accounting to variation on important prognostic variables, and the second one is to adjust comparisons between groups for imbalances in important prognostic variables between these groups. The term prognostic is given to some values of variables that are directly predictive by the model, such as temperature, water vapor, salinity, depth in atmospheric or ocean models, variables that can be directly obtained as a model outcome. Example, we are trying to assess the effects of teaching methods on the math achievement by comparing the average math achievement score in different teaching method groups after controlling the effects of IQ. Here there are three things we can see. Teaching methods, effects of in teaching methods on math achievement, and comparing the average math achievement score in different teaching methods, right? Math achievements and different teaching methods. In control variable is there, that is control means students IQ. So research question. So research question is, does teaching methods impact mathematics achievement controlling for IQ? So we can answer for the research question by using the by conducting an ANOVA test. So you will have to enter the data into the SPSS. So these are the data, so we can enter these data into the SPSS worksheet. And this is the dependent variable, as I explained in the previous slide, and this is the independent variable. And what is this? This is the control variable, or this called as covariate. Click on the variable view in the bottom left, and starting of the top far left column under name, type the variable names math, method and IQ. You know that how to enter those data, and label the categorical values. These are the method, and click on the value box on the categorical variables. So type 1 value in the traditional for the value label, click add. Type 2 value and traditional progressive for the value label, click add. Type 3, then click add, then click OK. So then click data view in the bottom left, add above data, and after adding data we will get this data window. So this is the way of we can add this data into the SPSS worksheet. And click on analysis, general linear model, univariate. So this is the steps we have to follow, and you can see this dialog box. Then click on the math in left on the box, this one, and we have to next dependent variable, math is dependent variable, you can take into here, and simply click on math left or drag and drop. So you can drag and drop to here, then you can take this for that box, and click on the method in the box in the left. This is the method, and that is the fixed factor. Method is that is independent variable, that is a fixed factor. And simply click on the method box, then left drag into the fixed box. And we know that control variable, that is covariate, IQ we have to take for this area, that is under covariate. That is explained in here. IQ in the box left you can take into the covariate, right? Then or simply click on IQ, then you know that. Then click on options, and so here we can check, we have to go to the options and click descriptive statistics and homogeneous tests in here, then click continue. Then we can go to the model, and you can see this. Then you have to click on the custom, check on custom, and change the box in the center from interaction, so it is interaction, so we have to change this into the main effects. And under the factors and covariation, click the method here. So then you have to take these two into that model box, then hit this arrow and click IQ, this one, then you can click center arrow, this arrow. So then you can take model both model to here, and this one is changed as main effects, and this is become as custom. Okay, so then we can come to this one, click continue and click OK. So then this is finished. Then we can, before see the SPSS output, we will go to the SPSS worksheet and practically do those. Right, you can see the entire data here. So what is our steps? We have to go to analysis, then general linear model and univariate. So then we know that our dependent variable is math, and fixed factor is the method, and covariate means our control variable, that is IQ. Then we have to go to the options, and we have to check the descriptive statistics and the homogeneity tests, then click continue. Then here significance level is there, and next we have to go to the model, then full factorial to model we have to change to the customs, then interaction we have to check to the main effects, and methods we have to take for the model method, and IQ for the here, right? Then click continue. Finally we have to click OK. Then we can take these outputs. Now we will consider how we can interpret those outputs. Right, you can see the SPSS outputs between subject factors, this first table, this one. So it presents the number of data points for each methods. So number of data points, traditional and progressive, then these three methods we can put number of data points equals 5. Each method has 5 data points. And this is descriptive statistics. It shows the mean value, standard deviation for each method, So you can see these things in this table. And Levin statistics of equality of error variances. So in the Levin statistics, that is display the test the null hypothesis, the error variances, the dependent variables equal across groups. So you need equal variances, that is you can see that is greater than 0.05. It means that what is it? It is null hypothesis and error variances of dependent variable equal across group, because this is greater than 0.05. The output present the results equality of the group variances. And the null hypothesis is that the groups are equal in the variance, and non-significant p-value indicates that assumptions is not violated. The next box displays the ANOVA results. So you can see the ANOVA results test between the subjective effects. So so these are the ANOVA results. So you can see these significance values, that is all are closer to 0.00, right? So then we can go to the next one. Table actually serves two purposes. First, we use it to test if there is a linear relationship between the covariate and the dependent variable, right? And the other one is, as we can see, there is a significant linear relationship between covariate and dependent variables, because this is less than 0.05, that is IQ and math. Yes, IQ and math, this one, IQ and math, if you see this, that is less than 0.05. So it means there is a linear relationship between these two, because we that is less than 0.05, because covariate in the relationship between covariate and dependent variable, the p-value in between these two less than 0.05. That is the way of we are interpreting those data. Here we see that the method of main effect, significant p less than 0.05, controlling the effect for the IQ. So what you have to check, covariate and dependent variable, right? So if the p-value is less than 0.05, there is a linear relationship between those two. So right, and the results if support the effect of the teaching method on students achievement after controlling IQ. So it can be taken as 26.736 and p is less than 0.05. so you can interpret this data into graph also. The profile plot give the visual picture of the giving with our study, right? As we can see, represent the estimated marginal means that math achievement and each of the test IQ. These are the references. So I think you have now clear understanding about ANOVA and ANOVA. So you can do the calculations using manually in ANOVA. So these learning outcomes we covered. What is ANOVA and ANOVA, theoretical background of ANOVA and ANOVA, types of assumptions in ANOVA, partitioning the variance in ANOVA, hypothesis, p-values, entering data, and commands used for the performing ANOVA, and also performing ANOVA and interpret the results. So I think now you have clear understanding about that lesson. If you have something to clarify further, you can contact me. Tutorial 7 is given based on this lesson. So then thank you very much.